I imagine that anyone that has ever been interested in numbers has been fascinated by primes. This is a program I wrote a long time ago in which I found all of the prime numbers between 1,000 and 10,000. Let me move this a little bit so it's not covered up there. Didn't want it covered up by this thing here. What happens in this program, and I'll move this back here. Well, first of all, I discovered something. I discovered that no sum of the digits of a prime is a multiple of 3. So let me pull this back down here, try to get it centered. All right, so what's happening here? I find all of the primes, there are 1,060 of them between 1,000 and 10,000. And then I count I add the digits. So I add 1, 0, 0, and 9. I get 10. All of the red numbers are 10 or less. All of the blue numbers are the numbers 11 to 20. So if the number is 20, as right here, if you add 2 and 6 and 9 and 3, you get 20. Okay, so all the blue numbers are higher than 20. Are between 11 and 20, and all the green numbers are over 20. So obviously here at the end you're going to have almost all green numbers. There are a few, like here's one that the digits add to 10, 9,001, but for the most part they're all green. Anyway, the fascinating thing to me about this, and I have no explanation for it, is that none of those 1,060 sums is a multiple of 3. But there are a number of other things that are fascinating about primes, and this is one of them. If you take the square of any prime number, let's say you start with number larger than 4, start with 5, take the square. That square, and all the squares here are in blue, that square is always the number 24 times some number plus 1. So 24 times 1 plus 1 is obviously 25. And 24 times 2, 48, plus 1 is 49. And that's true all the way through. So the square of any prime number larger than 4 is always a multiple of 24 plus 1. And the multiples of 24 are in green. Okay? So that's another little fascinating tidbit about primes. And today I explored another curiosity about twin primes. Remember that a twin prime are two prime numbers separated just by two numbers. So 11 and 13 are both primes, and they're two numbers apart. But this curiosity says that if you multiply those together and you get a number, and then you add those digits together, so you're adding 1 and 4 and 3, it will always resolve to 8. So I wrote this program to demonstrate that. If you multiply any pair of twin primes together to get a number, which we'll call the product, and then you add the product's digits together, the sum's digits, the product's digits, will always resolve to 8. And if the sum of the digits, for example here, the sum of multiply 29 and 31, twin primes, and you multiply them together, you get 899. Well, that obviously is larger than 8, right? So what you then do is you perform the addition again. So 29 and 30 times 31 is 899, which is 26, but then perform the addition together again with the digits that remain, 2 and 6. 2 plus 6 is 8. So that number resolves to 8. And I didn't have room to do all of the levels of addition, but you can get the idea. So as long as the sum of the digits is larger than 8, continue adding the digits with each new sum, and the result will eventually resolve to 8. That's just a program I wrote today. which is kind of fascinating. I actually did use my calculator to add these last three numbers, and sure enough, they all come down to 8 eventually. So thank you for watching.